Okay, so now we're going to deal with solving some different equations involving indices and surds. So we have this equation 2 to the x minus 3 equals 16. Um, we have two different bases. We have 2 and 16. In order to make a relationship between exponents, we need them to be talking about the same base. So we need to convert either 2 into a base of 16, or we need to convert 16 into a base of 2. Well, I know that 2 to the 4th power is 16. Or again, you could do this a different way. You could say that 16 to the 1/4 is 2. You could do this either way. It does not matter. I'm going to use the top. I'm going to use 2 to the 4th is 16. I'm going to say 2 to the x minus 3 equals 2 to the 4th power. Again, because these are the same thing. So here, now I have the same base, and I have different versions of an exponent. So I can say that now that x minus 3 is going to equal 4, and further that x is going to equal 7. So that is your solution. Now, if we have an equation with, let's say, lots of different numbers, we've got to somehow get this into terms of a single base. We've got 9, 3, and 27. Well, these are all linked with a base of 3. If you think about your power or your exponents of when you go through 3, we know 3 to the 1st is 3. We know 3 squared, 3 squared is 9, and 3 cubed is 27. So I'm just going to go ahead and I'm going to convert these. That's it. So I'm going to get that 9 is the same thing as 3 squared. And that 3 squared is being taken to the 5x minus 1. And you still have 3 to the x. That's already in base 3. And then we have 27 is the same thing as 3 cubed. Well, I need to simplify and rewrite. This side over here is, I've still got two different parts. They have the same base, so we can go ahead and start trying to put them together to make this problem work for us. On this side here, anytime you take an exponent to another exponent, you have to multiply those exponents. So you're going to get 3 to the 2 times 5x minus 1. We still have a 3 to the x here. And the bottom here, we can rewrite this as 3 to the power of 3 and the root of 4. So this is 3 to the 3/4. I can, again, further simplify. Over here, if I were to distribute the 2, I'm going to get 3 to the 10x minus 2. Now, we have the same base on top and bottom, and if I want to combine that into a single base, I need to subtract one of the exponents from the other. And if I would prefer to move everything to the top, I'd like to have my numerator be where my exponent is. So I'm going to subtract the 3/4 from the top, and I'm going to get 3 to the x minus 3/4. So this is an exponent. Okay, these are the same statements. I've just simplified. So now what I've got is I've got the same base, and I have two exponents that look different. So now I need to solve. Well, because they have the same base, I can go ahead and say that one of their exponents, 10x minus 2, equals the other, which is x minus 3/4. So I'm going to move this over. So I'm going to get 9x on this side. I'm going to then add the 2 over to the other side. If I did negative 3/4 plus 2, that's going to be the same thing as 5/4. I then am going to divide by 9 on both sides to get a single x. So I'm going to get x to be 5/4 divided by 9. Now, 5/4 is being divided by 9. dividing by 9 is the same thing as multiplying by 1/9. And so from here I can get 5/36. So this is my exponent here. And, or excuse me, this is my x. So this is the solution to this problem. Now, one particular type of problem that makes this a little bit more difficult is, let's say we start having things that are all separated. We have, 3 terms now. There's a particular way you go about solving this, especially when you see that we have, like a single x and a 2x here. We can think of this very quadratically because, and it comes down to this concept that, if you had, let's say, 3 to the x, if this was squared, that's the same thing as 3 to the 2x. Okay, so we are going to use this process of using a quadratic to help us solve this. So I'm going to turn this part, the one with the part with the 2x, into something with just the 2x, not the 1. So we can rewrite this as 3 to the 2x times 3 to the first. Okay, because remember when we multiply bases, we add their exponents, so those two things are the same. My 18 is fine, and my 25 times 3x is also fine, or 3 to the x, excuse me. So what I'm going to do now is I'm going to set this up like a quadratic equation. I'm going to have my 2x, kind of my square term, be out front. And so I'm going to have 3 times 3 to the 2x. Okay, so that's like my squared term. I'm then going to subtract this side over. That's my regular x term. I'm going to have minus 25 times 3 to the x, and then my minus 18, and that's going to equal 0. Well, what if I'm going to make this assumption here? I'm going to say that 3 to the x equals y. I'm going to go ahead and rename it, and it's just going to make things look a little easier for me. Okay, so if I were to do that, this would become 3 times y squared. Again, 3 to the x squared is 3 to the 2x. So since this is y, it would follow that y squared is going to be 3 to the 2x. So that's the move that you have to make in this problem. And this would be, and then minus 25, since 3 to the x is y, this would be y, and then minus 18 equals 0. So now this is set up in a way where you can use the quadratic formula, or you can factor whatever it is that you need to do. I'm going to go ahead and use the quadratic formula. If you have that, or if you want to factor, there's plenty of ways to go about that. You should find here that y is going to end up giving you either 9 or negative 2/3. Okay, so from here, because it's a quadratic, you need to go forth and check these numbers. Okay, so let's think of this. Let's think of these over here. So if 3 to the x equaled 9, what would x be? Well, x would have to equal 2, because 3 squared would be 2. Now, if I had 3 to the x equals negative 2/3, what would x be? Well, in this case, there are no solutions to this. There's no exponent, there's no number that I could take 3 to get a negative number. So this one's no solution for this part. So overall, your x value is going to equal 2. And that's because this value, the negative 2/3, cannot be used. And so I have to use the y equals 9, or 3 to the x equals 9. And so you would get x equals 2 would be the only solution that would work for this particular problem. Okay, moving on. So if, let's say we have simultaneous equations. So when we have simultaneous equations and we have to solve, we need to get one variable in terms of another, or we need to somehow get two equations that work together for us. Once we have two equations, we can then substitute and solve. So I want to get x equals some sort of y. Okay, so I'm going to work with each side of these separately. So this left side is the same thing as saying 32 to the x over 8 to the y equals 512. So I need every term to be in terms of a 2 in this case, because 2 is going to have a base for all of these numbers. So just quick review, right? 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16, 2 to the fifth is 32, 2 to the sixth is 64, 2 to the seventh is 128, 2 to the eighth is 256, and 2 to the ninth is 512. So you could always build this if you need. It's just multiplying by 2. So we're going to use this, okay? So 2 to the ninth becomes 512. So we get 2 to the ninth. 2 to the ninth. 32 is the same thing as 2 to the fifth. So this is going to be 2 to the fifth to the x. And then this will be 2 cubed to the y. Well, this is the same thing as saying, okay, well, 2 to the 5x over 2 to the 3y equals 2 to the ninth. Right? So now we can actually put these together. Remember, if we want to put these together, we are going to subtract. So we're going to get 2, okay, to the 5x minus 3y equals 2 to the ninth. So we have this set up, and we're going to use this later to figure this out. But we now have a way to relate our exponents together. We have a simpler equation that we can find. Now let's work with the other side. So our other side here, we have everything in terms of 3. Okay, so we have 3 to the first, that's 3. 3 squared is 9. 3 to the third is 27. 3 to the fourth is 81. 3 to the fifth would be 3 times that, which is going to be 243. 3 to the sixth is going to be 3 times that, which is going to be 729. These are common numbers, so we're going to use these different values to help us out here. Okay. So 3 to the 3x is normal, and we're going to divide, so I'm going to do this step together. So 3 to the 3x we've got in a form that we want. We're dividing that by 1 over 27, which is the same thing as 1 over 3 cubed to the 1 minus y. Okay? And that equals 3 to the 6th. So we want to go ahead and keep working. So we've got 3 to the x, or 3 to the 3x, excuse me, divided by, this is the same thing as 3 to the negative 3 to the 1 minus y equals 3 to the 6th, which we can say that that's 3 to the 3x over 3 to the, remember we multiply our exponents, so negative 3 times 1 minus y is going to end up being negative 3 plus 3y equals 3 to the 6th. And we can go ahead and finally get this into a form all together. So when we move one up, again, we take the whole thing, we subtract it away. So be careful when you subtract, okay? You're subtracting the whole thing. So we get 3 to the 3x. We are subtracting this whole thing, so if we subtract negative 3 plus 3y, right, we have to distribute that negative. So it's going to become minus negative 3, which gives us a plus 3. and then we have to subtract the 3y away as well. And that equals 3 to the 6. Well, now we have two separate things that, two separate parts that we can work with. Okay, so here I can say that 5x minus 3y equals 9. And on the other side, I can say that 3x plus 3 minus 3y equals 6. And I want to go ahead and kind of solve these. Now, one very easy way for us to go about doing this is we could solve for y. We could solve for y on both sides. That would allow us to converge the y's together, which is what I'm going to do. So I'm going to move the 5x over. I'm going to get negative 3y equals negative 5x plus 9. And then we can divide by 3 and divide by negative 3 on both sides. We're going to get y. And if you divide this whole thing by negative 3, you're going to end up with 5/3 x minus 3. So we're going to do the same thing on this side, except I'm going to move the 3y over and move the 6 over. You can get that 3x plus 3 minus 6 equals 3y when we move everything over. And so then I'm going to divide by 3 on both sides. So when I divide by 3 on both sides, I'm going to get y equals, okay, the 3x divided by 3 is going to make a single x. And then the plus 3 minus 6, well, you could think of it this way. This positive 3 over 3 is 1, and negative 6 over 3 is negative 2. So that would combine to make a minus 1. And so from here, I've got y equals this and y equals that. Well, I can just go ahead and converge those things together and say 5/3 x minus 3 equals x minus 1. And I need to solve for x. I'm going to move this over. I'm going to move this over. So I'm going to end up with 5/3 x minus x on one side, and I'm going to end up with negative 1 plus 3 on the other. Well, 5/3 x minus x is going to give me 2/3 x. This will give me 2. And so this would follow if I divided each side by 2/3. I should end up with x would have to be 3. So this is a lengthy problem, and we're not even finished yet because we have to solve for y. But thank goodness we have some simple equations for us to do that with. If we need to solve for y, we can take our x and plug it back in, and we're going to end up with y equals x minus 1. So y would equal 3 minus 1, which is going to be 2. So complicated problem, but it's one that you can solve. You just have to stick with it. Okay, so we have another example. Okay, so what happens if we have if we have a square root and other terms in the same problem? Okay, well, ideally, what you want is to have your square roots on a side by themselves, so that when we go through this problem and we square it, we can actually get rid of that square root. The other side, it doesn't have anything, and there's multiple terms there. You want as few terms as possible, because when we square binomials and trinomials, they create many more terms. But in this case, it's going to work out to our advantage. Squaring a binomial is not very complicated. But what you're going to want to do is we're going to want to try to free up our x. Okay, so the move here is going to be to square both sides. And so we have to square the entire side. Well, the left side, the square root of x plus 7 squared, is just going to give us x plus 7. Now, the right side, remember, when we square something, we have x plus 1, x plus 1, you're going to end up with many terms. You're going to get x squared, you're going to get a positive x, and a positive 1. So this side becomes x squared plus 2x plus 1. Well, you may say, well, that's not making things very easy, but you can see that this is going to be a quadratic equation. We just have to set it up for ourselves. We're going to move all this stuff over to the other side. So we're going to get x equals x squared. When we subtract the x over, we're going to get just 1x, right? We take the x away from the 2x, and then we're taking the 7, the positive 7, away from the 1. We're going to get minus 6. You can do the quadratic formula, or you can factor. I'm going to choose to factor. So this is going to be x plus 3 times x minus 2. Okay, so this would tell us that x could be either negative 3 or 2. Well, we want to go ahead and you want to make sure that you're checking things out. Okay, these type of problems, especially with quadratics, you want to check to make sure your answers make sense. Well, if we plug in 2 up to the top, we would get the square root of 9 equals 3. That makes sense. So that's good. So, we can go ahead and say, okay, well, 2 works. What about negative 3? If we take this up to the top, this would say, if we plugged in negative 3, we would get the square root of 4 equals negative 2. And that does not work. In this case, this negative 3 is not going to be a solution for us. It does not work for this equation. The only value of x that works is this. Now, quadratic equations can always be solved using factoring, okay? But the answers aren't always going to be useful, so you must check your answers. Now, take this to a new example. So let's say that we have, 3 times the square root of 2x plus 2 minus 2 times the square root of x plus 6. So how do we deal with this? Well, you don't want to square this side by itself. You've got 2 terms. You're still going to end up with square roots if you square this side. The best possible method, if you ever have to square both sides of an equation, is to try to get as few terms on each side as possible. So in this case, we have 2 terms over here, 0 over here. Well, squaring 0 is always great, but it's not going to help us in this problem because our left side is going to create more terms. I'm going to move one of these over to the other side to kind of even everything out. So I'm going to end up with 3 times the square root of 2x plus 2 equals 2 times the square root of x plus 6. So I'm just adding this term over to the other side. You could have subtracted the other term. Does not matter. You'd still be able to solve this problem. So now I'm going to want to go ahead and I'm going to want to square both sides to get rid of these square roots. So when you square something, you have to square every factor that you are squaring, okay? Every factor has to be squared. So this becomes 3 squared times the square root of 2x plus 2 squared. And that's going to equal 2 squared times the square root of x plus 6 squared. You have to square each factor. So this becomes 9 times 2x plus 2. Right? If we square a square root, that's what we get. And then 2 squared is 4 times x plus 6, because when you square a square root, that goes away. And so now you have a very balanced, easy linear equation to solve. And so we're going to go ahead and distribute. So 9 times 2x gives us 18x. 9 times 2 gives us 18. 4 times x gives us 4x. 4 times 6 gives us 24. And then we can go forward and solve this. Okay, we want to move all our x's to one side, everything else to the other. So we're going to move this over, and we're going to move the 18 over. So you're going to get 14x is going to equal 6. And therefore, you're going to get x, when you divide both sides by 14, you're going to get 6/14, which is the same thing as 3/7. So that's the solution to our problem. Lastly, we've got one more problem here. So, and this deals with the last concept we talked about, is if we end up with multiple parts where, let's say, we can't necessarily solve kind of in other ways, we can sometimes assume that certain parts are going to be equal to other parts. So this problem we've got 2 binomials being multiplied together, which means that we're going to have to FOIL. So we're going to FOIL this side, so we do our first, which is going to be 3 times 4, which is 12. We then do our outside, which is going to be 4 times x times the square root of 7, which that ends up being 4x square root of 7. We then do our inside terms, which is going to be negative square root of 7 times 3, which is going to be negative 3 times the square root of 7. I mean, again, when you multiply, the order doesn't matter. And then we have negative square root of 7 times x times the square root of 7. It's going to give us negative x square root of 7 times the square root of 7. And that equals, all right, our negative 2 plus, well, I'll get that part down later. So if we continue to simplify this side, we get 12, okay, plus 4x times the square root of 7 minus 3 times the square root of 7, and then square root of 7 times the square root of 7 is going to be 7, so we get minus 7x. Well, we can actually factor this down, okay? And when we factor this part down, we are going to see that, let's say we were to factor the square root of 7 out of this. It's in both of these terms, okay? So we're going to end up with 12, and we're going to have plus, if we were to factor the square root of 7 out of here, what's left? Well, we're left with a 4x minus 3. Okay? And this equals everything at the top, which was negative 2 plus y times the square root of 7. Okay? So we need to have this. We need to have our sides looking similar to each other. Okay? I want a term plus another term, or minus another term. So I'm going to reorder this. Okay? So just look at the left side. I'm going to put these two parts together. I'm going to say, okay, well, this is 12 minus 7x. All right? And then I have my extra part, which is plus 7. Plus 4x minus 3 times the square root of 7. Okay? And on the other side, I have negative 2, and then plus y times the square root of 7. So I can make some relationships now, right? I can see that, okay, this is just some term. There's no square root of 7 attached to it. So I'm going to match it up with that. And then also, I'm going to have that, I'm going to have this match up with that. Okay? So I can make these different relationships linked together for myself. Okay? So I can say, in the green, that 12 minus 7x equals negative 2. And when I solve, I'm going to move some stuff around. So I'm going to move the negative 7x over and the negative 2 over. So you're going to get 14 equals 7x, and that x is going to equal 2. Well, on the other side, I'm going to have that 4x minus 3 equals y, because those are both the coefficients of the square root of 7. So since I have this, I'm going to plug 2 in. I'm going to get 4 times 2, which comes from this side over here, right? And then I get minus 3 equals y. You should get 8 minus 3 equals y. So y is going to equal 5. So this is a way to solve this. Now these equations are, becoming more and more complex, but it's about making it set up in a way where we can say something about our variables. So a lot of times we have to manipulate these equations to look like things that we can work with. So that's a big part of this section, is manipulating these equations to make them workable for us.